this particular lecture is going to be about partitioning. And as you can see right here, I have some of your wonderful definitions that I know you all love so much. And I will be uploading these to Canvas for you so that you can fill them out and turn them in. And I'll put a due date on that. I'm not exactly sure when we'll do that. Definitely after the lab Monday, so maybe Friday or Saturday. Give you enough time to go through and do them. Okay, so this is going to be about formatting and partitioning your drive. So we talked a little bit about this in class. Let's go over it some more and make sure it's all within one section. So formatting. What is formatting? Well, this is the process of preparing the drive for use. And we already talked about in class, formatting does not delete the data. What does it delete? It deletes the partition table. It deletes reference to where the data is on the disk. And then creates a new partition table to be used with the new file system. So we have a couple different types of formatting. We have low-level formatting. This is done generally in the factory. This is when you buy a new hard drive, it comes low-level formatted. This is the actual process of dividing the disk into tracks and the tracks into sectors. Back in the old stepper motor days, this was actually done at home by the user. But now with the voice coil motor hard drives, it's done for us. So when we get a hard drive, we then have to high-level format it in order to prepare it for accepting an operating system. So high-level formatting goes through, removes the partition table, it creates a new one and for the appropriate file system, whichever one you chose, and creates a root directory. Now we have two different types of formats. We have the quick format that only removes the partition table and sets up a new one. And then we have the long format process, which removes the old partition table and then it goes through the drive sector by sector and checks each one and marks them out as good or bad sectors. Now, I am seeing here I told you it was FFFF and it marks it out as FFF7. So you can see that on here. So within the partition table, bad sectors will be marked out as FFF7. Okay, so now we've formatted it and we're setting up our partition table. Partitioning. What exactly is partitioning? And you'll hear two different types of terminology. You'll hear partition and you'll hear volume. And we're going to talk about the difference between those two because there is a difference. So partitioning a drive is the process of subdividing the physical hard drive into groups of cylinders. So we are using the actual drive geometry of the drive and we are saying we want a 10 gigabyte partition. And if you watch during the partitioning phase when you choose how big your partition is going to be and you say I want 10,000 megabytes, which is 10 gigabytes, it will then tell you how many megabytes exactly your partition is, and it's never 10,000 because remember a gigabyte is 1024 megabytes, so there's some math there that's not going to work out exactly. And the other thing that's happening is that you are physically separating these partitions from cylinder to cylinder. So however many megabytes that approximates 10,000 is what's going to be your partition, as long as it fits between two sets of cylinders in that approximate range. So partitioning is used with basic disks. Basic disks consist of two data structures. You have your MBR, which is the master boot record, and you have your partition table. And these things are both stored in the first sector of the hard drive. When you use basic disks, you can separate your drive up to 4 partitions. Now, you have different types. You have your primary partitions and you have extended partitions. So primary partitions are ones that can support an operating system, and you can have up to 4 primary partitions on a single basic disk. Or you can have up to 3 primary partitions and 1 extended. You cannot have more than 1 extended partition, so you are limited there. And then within extended partitions, you can create logical drives, which I do not have on my definitions. But logical drives are, this is where we're going to work into volumes. Logical drives are like partitions in that you're saying, I'm saying this many gigabytes, this 5 gigabytes is going to be this one particular logical drive. That's a volume. You're not separating out that 5 gigabytes from one sector to another sector, or sorry, from one cylinder to another cylinder. It's just grabbing a group of sectors, however many sectors it needs to make up that 5 gigabytes. And it's possible that it may not even be contiguous. We hope it is, but they're logical. So whatever sectors it has available, you can create them at any time. It will use those. So it's not structural like a partition. So your extended partition, it's basically created out of anything left over after your primary is created. Generally not bootable, and I mentioned this in class. You can put bootable operating systems in extended partition space, but it requires a little hackery and deceit. So it's not officially supported. Remember that. For the test, essentially, you can put nothing bootable in extended partition space. But you can divide it into many logical drives. You have 26 drive letters to work with. Some of them are reserved, and whatever you have left over, you can create as many logical drives as your little heart desires, up to 26. So, volume boot sector. Okay, this is the first sector of the first cylinder of each bootable partition, because each one's going to have a boot sector for that particular operating system that you're going to put into it. This is going to store information which is important to booting the files, or booting the operating system. So you're going to have operating system boot files in there. Your master boot record, and it's going to say, well, my operating system is here, so look here for finding operating system files to boot that. Other types of partitions that we have to work with are hidden partitions, swap partitions. So a hidden partition is one that can only be seen by the BIOS, and this is commonly used as restore partitions by computer manufacturers. So remember, they don't send you disks anymore if you need to rebuild your computer back to factory specifications. Instead, what they do is they put the image that they use for the operating system in a hidden partition. And you can boot to this hidden partition, and it's like booting off the disk, and it just reinstalls the operating system for you. It's not, you don't see it in Windows. Swap partition, this is used by Linux. Remember we talked about this. Instead of using a page file, they use a swap partition for the paging. And partition resizing. Alright, so within Windows, we have the option to resize partitions to a certain extent. So if we go into computer management and go to disk management, and we can see our disk here. Now I just have my one 60 gigabyte partition. Technically I could try to make this smaller if I have some space left over, which I do. I'm not using this. I just installed this Windows 7, so we can go ahead and we can see that I'm using about 9 gigabytes, 10 gigabytes. So I have 50 gigabytes free of my 60 gigabytes. So I have all of this space, and if I wanted, I could potentially shrink this partition down some and then gain some extended space, or gain some extra space, maybe create another primary partition, install another operating system. And right now that would not be detrimental. And the reason that would be okay is because I just installed this operating system, and the way the operating systems write to the hard drives, mechanical hard drives, is that it writes into the first available sector. So it should start at the beginning of the partition and write out. And nothing else has been done with this yet. It was just installed a few minutes ago. So Shrinking the partition probably would not have any detrimental effects to the current running operating system. You need to be really, really careful though, because if you've been using your operating system for a while and you've gone and you've filled up all your hard drive space and then said, oh, I want to create another partition, I want to shrink this one, and you went and you clear out a bunch of space and say, okay, now you go in here and it says, okay, you've got 50 gigabytes available, but it's just showing you how much total space is available. It's not showing you what data is written into what sectors. You can't see that through this. So you may have, even though all the space is available, you may have data written into sectors that are towards the end of the partition, and you go and you cut it off right here and say, well, I'm going to take, 40 gigabytes of this and make a new partition. You may have files out here, system files, drivers, that were sitting out here and got written out here that you're now removing, and your operating system could become no longer operable. So there is a huge risk in shrinking your partitions. Expanding your partitions, not a big deal. So if I had taken this and it had cut it off right here and said, okay, well, your C drive is 40 gigabytes and you have 20 gigabytes of free space, then I can just expand into that free space, and that doesn't hurt anything. Now, the partition resizing is available to go bigger or smaller in both Windows Vista and Windows 7. Windows 8 supports that too. But that was not supported in XP or 2000 and all of it. You could expand a partition. You could not shrink a partition. You would have to use something like Partition Magic to do that. You couldn't do it natively. So Windows 7 is when they started, or Windows Vista is when they started supporting that. Alright, so dynamic disks. This right here, this is a basic disk, and you can see that because it says type basic. And one of the things that I could do is I can actually convert this to a dynamic disk. Now, dynamic disks deal in volumes. So if I convert it to dynamic disk, I am working with volumes at that point. Everything becomes logical. I can keep to my one single hard drive that I have, and this isn't even an actual good representation because this isn't physically what I have in my computer. This is a virtual machine. So this is a file. This hard drive is a file sitting on my bigger hard drive from my host computer. But you can play with all the drives in this, and with virtual machines, you can just create a whole bunch of virtual hard drives and stack them all up, and you can convert to dynamic disks, and you can span them, which is what I'm going to talk about. So you have simple volumes and you have span volumes. So a simple volume means that the entire volume is contained within one disk. So I convert to basic disks, and it's literally just right-click, convert to basic disk. You convert to basic disk, and then, convert to dynamic disk. So you convert, and then you're dealing in volumes. And if I had multiple hard disks in here, I could then choose the multiple hard disks, and I could choose to span them. You can span up to 32 disks with dynamic disks. The other thing you can do with dynamic disks is you can create software RAID. So if I have multiple disks in here, I could choose 3 disks and say I want to create a RAID 5. Now, this is a software RAID, so now your operating system is managing your RAID, and we've talked about the risks of that before. Okay, so simple volume, 1 disk. Span volume is the volume extends over multiple disks, and it will show up as a single volume. Okay, partitioning utilities. What sorts of utilities can I use to partition my drives? Well, I have fdisk, which is old, tried and true. This was used in DOS and Windows 95, 98. Do remember, I haven't mentioned this before, that Windows 95 and 98 are DOS with a Windows GUI on top of them. They weren't actually Windows. They were DOS based. So fdisk was used to partition files for DOS, partition disks for DOS. It's just a tiny little utility that comes on within Windows, and usually you ran it off a floppy drive, Now you can use utilities to put it on a thumb drive if you really wanted to, and you can boot off that and run fdisk. It only supports the FAT file system, which I'll talk about in a minute. It's great when you get a low-level formatted hard drive and you just need to format it so that you can do something like image the drive, because tools like Ghost won't see the hard drive unless it's been high-level formatted in some way. So I used to use fdisk and format the drive really quick, and then I could push my image down onto it, and my image would slap everything on there appropriately. So it didn't matter what I did with fdisk, but it was formatted then so that Ghost could read it. Disk management, which is what I have open here. And this lets you manage your disks to a certain extent. You have a little bit of options, shrink your volume, change drive letters and path, extend my volume. This is if I had converted to dynamic disks. Format it. And notice all these are grayed out. And some of them are grayed out because, well, I can't extend my volume because I'm running a basic disk. I'm not a dynamic disk. I can't add a mirror because, once again, I'm running basic, not dynamic. I can't delete it because, well, this for two reasons. One, it refers to dynamic, and two, I'm using it. So I can't format. I'm using it. So these are things I cannot do. If I had another partition in here that didn't have Windows on it, I would have a lot more options with it. You are somewhat limited as to what you can do with the partition that is actually in use, and that's a good thing. You don't want to destroy your operating system. And another tool that I am a huge fan of is called diskpart. So if I open up the command prompt and I type in diskpart, and I can go in here and I can say list disk, and it's going to show me I have one 60 gigabyte disk. So now I want to inspect that disk a little bit. I say select disk. Oops. Disk 0. I have to tell it what disk I would like to select. And read your error messages. This is a good lesson right here. The arguments specified for this command are not valid. For more information, type help select disk. So if I didn't know the full command and I had just tried to guess at something, it shows me what the help is. And I can say help select disk, and then it's going to tell me what my options are. And I'm going to tell you right now the option is that I didn't tell it which disk to select. Diskpart's really intuitive. So disk 0 is now the selected disk. So now I want to see what volumes I have on the disk. And I know I told you, oh, they're partitions, not volumes. Windows 7 calls partitions volumes. It uses it fairly interchangeably, even though volumes refer to logical separations and partitions refer to physical separations. It's still used interchangeably. So you do have to watch that. Know what the difference is, but be aware that you can go ahead and use them interchangeably. And it is starting to become more interchangeable, especially with the advent of SSD drives. They don't have cylinders. And the expansive use of virtual machines. I mean, these are not physical hard drives, they're files. So we're going to say list volume, and it's going to show me that I have a volume 0, which is my DVD-ROM drive, and I have volume 1, which is my current operating system partition. And then I can go through and I can create new volumes if I had some extra space, if I had some on-partition space. I can create new volumes, I can delete volumes, I can rename drive letters. You have a lot of options in here. Basically anything that you can do in diskpart or in disk management. Diskpart is the essentially command line version of disk management, but it's much more powerful than disk management, and it will let you do things that disk management will not to a certain extent, and you can really destroy your partition and your operating system if you're not careful. There's no fail-safes in diskpart like there is in disk management. So you want to be a little bit cautious, but diskpart is a fabulous tool and super quick and easy to use. And I actually prefer it over disk management. Alright, so I'm going to say exit because I would like to leave that. Now I'm back at the command prompt and I can carry on with whatever command line business I have. And then our last utility is gparted, and this is the one we're going to use in class. And this is just a Linux utility for partitioning drives. And it's kind of fun because it'll let you create all sorts of partition types. Alright, So, and the last option in this section is multi-booting. And I left you a link right here, and you'll see this link. You can go check it out. Multi-booting is starting to go the way of the dodo bird. Why? Because we have virtuals. Why have multiple operating systems that you have to boot into when you can just have virtual machines? If I was multi-booting and I wanted to show you, I'd have to reboot my computer, which wouldn't work because then it would shut down my recording software. So I have a whole operating system, a whole separate operating system from my host operating system that I can show you that's completely sandboxed and not dangerous to my system and my network. If I wanted, I actually have it set up as a bridge connection, but if I wanted to, I could isolate it and sit here and show you this. And if I destroy it, if I go in here and I get crazy with this part and delete my volume, you know, who cares? Just create another one. It's just a virtual. It's not a big deal. Alright, so multi-booting used to be because you wanted to run multiple different operating systems, but you do have to reboot to access the operating system. Alright, so file systems. So we've talked about partitioning the drive. We've broken it up. We've formatted the drive. So we've removed the old partition table. Well, part of the formatting process is saying, well, I want to use a different file system. So I have to choose what file system I would like. You can see that this one here is using NTFS, and we're going to talk about the different file system options that we have. And the two we have for Windows are FAT and NTFS, and FAT not so much anymore. You actually can't install Windows 7 in a FAT partition. So old one, FAT16. There's actually a FAT12 that was used for floppy disks. Throw that out there. I keep seeing it pop up in my A+ texts, and so, you know, if you were curious, FAT12 is for floppy, so if you see a question about that, you know what it is. FAT16, this was used in DOS. It supported file names of up to 8 characters plus a 3-letter extension. So, for example, you could have 1, 2, 3, 4, 5, 6, 7, 8 dot FAT. This is the most you could have. 8 characters plus a 3-character extension. That's it. Now, and it's a 3-character extension. So, what about a file name like supercalifragilistic.docx? Well, that's not valid in FAT16. I'm going beyond 8 characters for my file name, and I have a 4-character extension. 4-character extensions are now possible, but they were not in FAT16. The other thing is that your volumes could not be any larger than 4 gigabytes. Oh, and you could not put spaces in your file names either. Now, you still get this way. I still get this way. No spaces in your file names. Mostly I say it because if you have to write scripts for anything, you have to put quotes around everything. Anytime you have spaces to indicate that that space is not starting a new command or parameter, you're indicating that you have to put quotes around it so you can say, well, no, this is all part of the same. So I'm still kind of crazy about not putting spaces in your file names, but you couldn't have them in FAT16. So, yeah, and 4 gigabyte partition size limit. That was not very useful to us. So FAT32, we started using FAT32. One of the problems with, FAT16 was that as hard drives got bigger, we started getting, close to that 4 gigabyte limit, and, our cluster sizes were getting so big that it became very slow and cumbersome to use that file system. So FAT32, this gave us file names of up to 255 characters, and you could have extensions that were greater than 3 characters. So supercalifragilistic.docx would be perfectly valid in FAT32. You could also put spaces in the file names. Your volumes were limited to 2 terabytes in FAT32. Our next FAT is FAT64, which we did talk about in class. They call it XFAT, extended FAT. This is used for removable media. And basically, this gets us the same benefits as NTFS, but without some of the limitations of NTFS, some of the features of NTFS that can cause us problems, like the caching. So it's a little bit more effective for removable media, but gives us the larger file sizes, because with FAT32 you cannot have a file size greater than 4 gigabytes, and that's not reasonable if you're moving virtual machines. I mean, my virtual file, or my file size for this virtual machine is, I'm sure, around 7 gigabytes. So that makes things very difficult when you're trying to put things on removable media. Let's see, let's pull it up. Oh, I've got it in multiple files, so that won't work. So exFAT supports the higher file size limits and of NTFS, and also supports ACLs, so access control lists, so we can have security on our files. You don't have any of that with FAT32, and that's a huge limitation. So that was one of the reasons we needed NTFS. We have these 6 features, and these 6 features are extremely important. We have the ability to impose security on our files and folders. We can compress files and folders. We can encrypt files and folders. We can impose disk quotas on our users to prevent users from using more space than they should. We can adjust the cluster sizing. We can go from 4K bytes up to 64K byte cluster sizes. And this, so larger cluster sizes will allow for larger partitions, but the larger your cluster size, the slower it is for you to use that particular file system. It's just like a file drawer. Think about it like, always go back to the file drawer. You have a file drawer and it's got 10 folders in it, and each folder has 20 pieces of paper, but you only have 10 folders. It's not very hard to find what you're looking for. If you have a file drawer that has 100 folders in it, it becomes more tedious to look through it. And it's the same thing with the cluster sizing. And then redundancy. I'll start with redundancy because that one's quick and easy. Redundancy just means that there's a copy of the partition table in the center of the partition. So NTFS has some fail-safes. If the partition table gets corrupted, it has a backup. And adjustable cluster sizing, so disk quotas, encryption, compression, and security. So let's go back to the virtual machine to take a look at those. So file security. So I've gone in here and I created a folder called test stuff. And if I go into the properties of test stuff, I have some tabs here that are very handy for me. So I can go into security, and I will see right here that I have an ACL attached to this particular folder. Now, if I wanted to, I don't have any extra users created in this virtual machine, but I could say, add some users, and I could say, Sally, if I click edit, we will get into ACLs more when we get into operating systems. For now, just here's a quick rundown. Here's how you manage your ACLs. I could say add a user, and I would type in Sally's name, and it's not going to find anything. Because I don't have a Sally. But I could say, okay, I want Sally in here, and let's pretend that, this group here is Sally. And I'm going to say Sally gets full control of this particular folder. So she can come in here and she can go all the way to modifying permissions. Sally is queen bee. And then I'm going to add Bob. And let's pretend Bob is this group here, and Bob is inheriting permissions, so I can't change anything. They're all inheriting permissions except for Sally. So I don't have anybody else I can add. I can add myself. So I added myself in here, and so let's say I'm not very trustworthy. So I don't even get read and execute. I can list folder contents and I can read the files, and that's it. Those are all the permissions that I get. And so you can limit who is able to do what with the different folders on the computer. And that's extremely handy. The other thing that I can do is over here on the General tab, if I go to this Advanced button, I have some options in here to compress or encrypt. So compression shrinks the folder. It compresses the folder if possible. Some things don't compress very well. Some things do. If it's already a tiny file, there's not going to be much to compress there. If you have a whole bunch of tiny files in there, you really aren't going to be able to compress it. If you have really large files, you generally can compress those a little bit more effectively. So, it says compress contents to save disk space. Basically, you're compressing them down to smaller size. This was really important when NTFS first came out because you had such small hard drives, and you would generally have one computer for many users, and so you wanted to be able to compress the files so that you could, use your hard drive space sparingly and didn't run out. The problem with compression is that it takes resources to compress and decompress every time those files are opened and closed, so it would slow the computer down. The other option is to encrypt the data. So if I check this box, it encrypts the contents to secure the data. Now, the person encrypting this, the person who selects encrypted, is the one creating the encryption keys. And one of the things you need to know about encryption or EFS encryption, encrypting file system, is that it uses your username and password to create the encryption key. So if you have to brute force your password for any reason, so you do not use a password reset disk, or you do not properly change your password where you put in the old one and then enter a new one twice, you break that encryption key. So if you use something like the Ultimate Boot CD to crack the password, breaks the encryption key. And you will no longer be able to access that file anymore until you change that password back to the original password. So that is a problem. The other thing is that you cannot both encrypt and compress. You have to do one or the other. So both of these are not options. EFS is still used today. It's a decent option if that's the only encrypting mechanism you have available to you. So it's definitely a fair option to use, but it's kind of tedious to manage. It's folder by folder, really. It's not more global like BitLocker, which we'll talk about in the security section. BitLocker is a full drive encryption. Alright, so we hit security, compression, encryption, and we still have disk quotas. Okay, so if I go over here to my computer and I go to the properties of the disk, I can go to the quota tab and I can show quota settings. And this is where I would enable quota management. And I would say, okay, well, users are limited to this amount of disk space. And it basically limits their profile, essentially, what they can write to in their profile. Because your profile is where you store all of your user data. Your My Documents lives in there. We can do a quick preview of that. So if you go into your C drive and you go to users, see this Documents and Settings? This is what it used to be called in Windows XP. And it's there, and you say, well, that's strange, why is it there? And if I click on it, I'm going to get access denied, because this is a virtual folder. This is a symbolic link. So for old programs that still want to use Documents and Settings, when they go looking for Documents and Settings, this is redirecting to users. And it maps everything that used to be in Documents and Settings to what is now in users. So this is my profile, and I have everything turned on. I have all the hidden folders and protected operating system files turned on. So you see a lot more in here than you typically would. But this is where you save all of your user data. So here's my documents, here's my downloads, here's my desktop, here's my Internet Explorer favorites. And you see all kinds of fascinating things we'll talk about later, like ntuser.dat, which is your registry file, stores your user settings. So this is where user data would be, and this is what we would typically quota enforce. Alright, so that about covers it for file types and drive partitioning. We didn't really go over the Linux file types, the EXTs. There are a lot, and we should give you this assignment where I have you go and Google Linux file partitions or Linux partitions, and give me a list of 10. There's a lot more than 10. The most common one used today is ext4. When we play with gparted, you will see how you can create Linux partitions. So we'll do that in class on Monday. So I think that about covers all the talking portions, and on Monday we will be able to play with all of this technology. So have a good rest of your weekend.